Hey guys, Mrs. Dan's here. Sorry you can't be in today. You all got your new workbook. We're starting our last unit, believe it or not, before we do review for our final exam. This last unit actually will feel like a bit of review, especially today. So we're going back to graphing linear equations. So we are on lesson 1, and we will be graphing linear equations using the slope and the y-intercept. But what we're going to do is graph more than one equation on a graph. And our goal or our objective today is to actually find the point where the two lines cross. And the place where the two lines cross is actually called the solution to the system of equations. So you have a do now on page 1. You could get started with that, and I'll be doing it in my video. We will do the lesson together, and then you'll be able to start your homework. Your homework is on pages 4 and 5. Of course, you should be prepared for me to check to make sure you took all of these notes, and let's get started. So just a bit of a warning, my pen that I'm writing with right now on the screen really is giving me a hard time. So my lines might not look very straight. I'm going to do the best that I can. But a little bit of review. When an equation is in the form of y equals mx plus b, remember we can state what the slope is and what the y-intercept is. So this equation is in the form of y equals mx plus b. So m is actually the 2 and b is actually the -3. Remember, slope is m, y-intercept is b, so the slope is 2, while the y-intercept is -3. We do like the slope to look like a fraction, so instead of 2, I'm going to write it as 2 over 1. Now that we know the slope and the y-intercept, we can graph it. Remember, we always start at the y-intercept. It's a y-intercept, which means it's on the y-axis. So right here, -3 on the y-axis. Remember, the slope is actually a staircase. So the top number is what we either go up or down. When it's positive, we go up. So I'm going to go up 2, and then to the right 1. What we learned in the past was that we always move to the right. So this staircase is going to go up 2, right 1, up 2, right 1. So we're going to start at the y-intercept and go up 2 boxes and right 1 box and put a point. And continue up 2, right 1. Try and keep up with me so that we don't have to hit pause too often. Now, the one thing that I also taught you in the past is that I like the points to go to the edges of the graph paper. So I want as far up and right as I can go. But how about if we continue in the other direction? Looks like it could go down and left to get a point here and here and here. And now I got as many points as possible. And now I'm going to draw a straight line. Sorry, my line's not perfectly straight, but I did put arrows at the ends because lines do go on forever. And we have to label this because we're going to graph another equation on the same set of axes. When we label it, use the line as like a guide. Right along the line here, y equals 2x minus 3. And now let's look at the second equation. If we put y equals mx plus b above it, I can circle the number that stands for m, which is a -3 over 2. And remember, m is your slope, and then I can circle what stands for B, which is a 4. So the y-intercept, or B, is 4. So remember, we're going to start right here. Start. Oh, my pen is terrible. So we start at 4. Since the slope is negative, this one we go down and right. I'm just going to pick a different color. And I'll start at 4. And I'll go down 3 and right 2. And I already found where they cross. I'm going to circle it. Down 3, right 2. And I'm going to go in the other direction. Up 3, left 2. And then I'm going to do the best job I can at drawing a straight line. Ooh, kind of impressed myself there. And we write the equation. Y equals negative 3 over 2x plus 4. The point that I circled, that's called my solution. Solution. Sorry, it's a bit messy. But there we go. That's actually today's full lesson. We're just going to explore a few things. So it tells us here that a system of equations is 2 or more equations. And to solve it means to find x and y values that make all equations true. So this is a super important statement. The x and y values that we use to make all equations true is the point of intersection. So what is the solution to the system of equations presented in the do now? Well, we already said it. It's that point of intersection. But we have to name it as a point. Isn't that the point 2, 1? Right? It's 2 to the right and 1 up. 2, 1. Now the correct solution will make both equations true when we substitute in the x and the y, which really means we have to do checks, right? So in place of y, we put a 1. Remember, this point is x comma y. So in place of the y is the 1. In place of the x is the 2. If we did this right, this equation will work out. This is a 4 minus 3, which is a 1. And over here on the left side was a 1. This checks out to be true. How about the next one? In place of y, we put the 1. In place of x, we put the 2. Now, if you need to use your calculator, then do so. Negative 3 over 2 times 2 is actually a negative 3. And negative 3 plus 4 is 1. So guess what? This check worked also. If only one of the checks works, it really would mean that I made a mistake probably while I was graphing. It's possible for it to work in one equation and not the other, but that doesn't mean that you did it right just because it worked in one of them. It actually has to work in both of them. So don't say, oh, it worked in one, I must be okay. That's not true. It has to work in both. So let's do another one. So in exercise 2, they're asking the question, is the coordinate point 6, 11? Remember, 6 is an x value, 11 is a y value. Is 6, 11 a solution to the system of equations of y equals 1/2 x plus 8 and y equals 3x minus 7? And it tells us to justify. So really they want us to do two checks. I have to check to make sure when x is 6 and y is 11, make sure it works in both of them. They're asking, is it a solution? So it might be no. I don't know. I actually have to do it myself. So I'll write the equation. Y equals 1/2 x plus 8. And in place of y, I'll put the 11. In place of x, I'll put the 6. And I'll do the math. Half of 6 is 3. 3 plus 8 is 11. It worked in the first one. I don't know, I got to do the second one before I say yes, it's a solution to the system. Right now, yes, it's a solution to the first equation. Let's do the second equation. Y equals 3x minus 7. In place of y, I put an 11. In place of x, I put the 6. And 3 times 6 is 18. 18 minus 7 is 11. Guess what? Yes, it's a solution to the system because it worked in both checks. Again, sorry about the writing. I'm going to have to try and find a new pen one day. All right, so exercise 3. We have to solve the system of equations shown below graphically. Okay, so it's very important that we're paying attention to these words because another day we're going to be solving algebraically. When it says solve graphically, you have to tell me what the slope is, what the y-intercept is, and then graph it using the slope and the y-intercept. So in the first equation, the slope, remember, is the coefficient of x. So in front of the x, it's a 1. And we like the slope to look like a fraction, so I'll write it as 1 over 1. And the y-intercept is 3. So we start at 3, and we go up 1, right 1. And I like to extend in the other direction. I go to the edges of my graph paper. I do the best job I possibly can, drawing a straight line, put arrows, label, y equals x plus 3 is the label. And then we graph the other one. I'm just going to change colors. So the slope is negative 1/2. And the y-intercept is positive 9. So I start at 9. Since the slope is negative 1/2, I'm going to go down 1 and right 2. Again, this is review. We already know how to graph. If for some reason you had a hard time graphing in the past, hopefully this is now easy for you. You know, as time goes on, things do get easier, but you do have to remember that you start at the y-intercept and then you use the slope to make your staircase. So this is where I started. And then since this was negative, I went down. And then right. And remember, right now, I actually didn't solve it. Even after I draw this line, All I did up to this point was show work. The solution is that point of intersection. I have to write it down in parentheses separated by a comma. That point is at 4, comma 7. The solution is 4, 7. Also, I forgot to label this blue line of mine. Y equals negative 1/2 x plus 9. Sorry, it's a bit messy. Oh, let's do the checks. Y equals x plus 3. Here's my x. Here's my y. In place of y, I put a 7. In place of x, I put a 4. And guess what 4 plus 3 is? So the first check worked. The second check, write down the equation. Y equals negative 1/2 x plus 9. In place of y, put a 7. In place of x, put a 4. Do negative 1/2 plus 4. Again, you're allowed to use calculators, so if you need to use a calculator, go for it. But what's half of 4? It's 2, right? So a negative times a positive is a negative. So this is negative 2 plus 9. And guess what negative 2 plus 9 is? It's 7. So this check worked also. So on exercise 3 right now, I just got full credit. I graphed both lines. I put arrows at the ends of both lines. I labeled both lines. I circled the point where the two lines crossed, and I wrote the solution as an ordered pair. Then I did 2 checks. So let's do it again. Exercise 4. So this is a great one to practice because sometimes in the past some students would get confused on how to graph an equation like that first one. So we can see if I write y equals mx plus b above this. Some people say, Miss Dan's, there's nothing where the b is. That's right, there's nothing. What is nothing? It's a 0. So I could pretend there's like a plus 0 here. And then some people even say, Mrs. Dan's, there isn't anything where the m is. Well, remember, there's an x here. How many x's? Remember, you don't have to put those ones. There's a 1 there. It's just kind of invisible. So my slope is actually negative 1 because there was a negative in front of that x. And I always make it look like a fraction by putting a 1 underneath it, which means I'm going to have to move down and right. And then my b, which is my y-intercept, is 0. So I start at 0, and I go down 1, right 1. And of course I like extending in the other direction. So the opposite of down and right is up and left. And I connect with the straightest line I could possibly do. Put arrows, label, y equals negative x. And now the second one, the slope is the number in front of the x, which really is a negative 1. I like it to look like a fraction, So I'm going to write negative 1 over 1. And the y-intercept, don't forget to take the sign with the number, it's a negative 2. So we'll start at negative 2, and we go down 1 over 1. This is interesting, isn't it? Why do I find this interesting? I hope you all said, because these lines aren't going to cross. These lines have the same slope. Lines that have the same slope will never cross because it makes parallel lines. But we had said that the solution to a system of equations is the point where the lines cross. So if the solution is the point where the lines cross, but they don't cross, what would you say? Yeah, there's no solution. So I'll label this y equals negative x minus 2. And I'm going to say no solution. Okay, so I guess sometimes you can't find a point of intersection because the lines are parallel. When lines are parallel, there's no solution. And let's graph this one. So the slope is a half. There is no y-intercept that I see, which means it's a 0. In the second equation, the slope is 3, and I can write it as 3 over 1. And the y-intercept is negative 5. And we will graph those. So I just graphed the first line. Since the slope is a half and the y-intercept is 0, you can see I started at 0, and a positive slope means I go up and right. And my line's not super straight, but there is the first equation, and I did label it as well. My second equation, I'll start at negative 5, because the y-intercept is negative 5. My pen is a pain in the neck. So the y-intercept's negative 5, and the slope is 3, but we always want the slope to look like a fraction, so we put a 1 underneath it. Because our slope has to be a staircase, remember. So we're going to go up 3 and to the right 1. And we're going to start at negative 5. Up 3, right 1. And I found the point of intersection right there. Sorry about my messy lines. So I fixed my lines a little bit so it looks better. They're definitely crossing at 2, 1. I do have to do a check to make sure. So if they're crossing at 2, 1, 2 is the x, 1 is the y. And 1/2 times 2 is 1, so it works there. And y equals 3x minus 5. In place of y, I'll put the 1. In place of x, I'll put the 2. 3 times 2 is 6. 6 minus 5 is 1, so it works. Okay. One more practice together, and then you can do your homework. So in the first equation, the slope is 3 over 4, and the y-intercept's negative 3. So if you could graph that and then check it with what I have. So here's my first line. Make sure yours looks the same. And I'll graph my second line. On the second line, the slope is negative 1 over 4, so I'm going to have to go down and right. And the y-intercept's 5, so that's where I'll start. So you could see the way that my second line slants. You could see I circled the point where they intersect. You could see I have arrows at the ends of both of my lines. You could see I labeled both of my lines. But one thing I didn't do was name the solution. Like, this is a common mistake. A lot of people will do this and think that they should get full credit, but you never answered the question. You have to tell me the point of intersection. So right here is my solution, and that's at 8, 3. 8, 3 is the solution. 8, 3. Sorry for my messiness. 8, 3. That's the solution. I have to do checks though. So you always write down the original equation. You plug in numbers. In place of y goes the 3. In place of x is the 8. And 3/4 times 8 is actually 6. And 6 minus 3 is 3. Works in the first one. And the second one, y equals negative 1/4 x plus 5. In place of y, put a 3. In place of x, put an 8. This is negative 2. And negative 2 plus 5 is 3. Guess what? The other side was 3. So it works. And that's it. Should have felt like review, hopefully. You can start your homework, the next 2 pages. Remember, you have to label your lines, you have to put arrows, and you have to state the point of intersection. The only time that you don't state the point of intersection is when the lines are parallel, because guess what? They didn't intersect. So I'll see you soon. Graph carefully. See you later. Bye.